So, so the first thing is to introduce it, to define it. What does it mean for a number to be in index form? So when a variable or a number or an expression is raised to a power, for example, if I have a raised to the power of x here, then we have written what is said to be an index number, where a is the base and this x here is the power. So basically, when we have any number, for example, if I use a real number now, if I use 2 raised to the power of 5, for instance, that is an example of an index number. So when we raise number to a power, when we write a number as a power, then that is indices. So we'll be looking at some basic rules governing the operation of index numbers. Then we'll also look at how to define, how to identify what an index number is. And basically, that is what I've just explained. Anytime a number is written raised to a power, then that is an index. That is an index number. So, going ahead, there is what I would describe as the invisible index. It is important to mention this because usually students encounter problems whereby they are asked to express a certain number in index form, and they encounter numbers like maybe 2, for instance. How do they break this down? So this is an invisible index. Any number that is, that kind of have an invisible index is not actually, it does not mean we cannot express it in index form. All numbers can be expressed in index form. For example, 2 now that cannot be broken down into any index form is said to have the index power as 1. So this is 2 raised to power 1. If we have a similar number, like 7, for instance, in index form, it is 7 raised to power 1, like that. So, what are the rules of indices? I will quickly summarize the rules of indices. The first one is when we have a raised to power x, for instance, multiplying, so the next one, if we have a raised to power x, for instance, multiplying a raised to power b, this is simply saying when we have two numbers with the same base multiplying, two index numbers with the same base multiplying, what we simply do is we add their powers. So this will equal a raised to power x plus b. What we simply do in this case is we just we add their powers. For example, if we have, let's say, 2 raised to power 3 times 2 raised times 2, and bringing the invisible index notion here, sometimes students assume that this 2 has no index. Some take it as 0. This will just simply be 2 raised to power 3 plus 1, which is equals to 2 raised to power 4, because the invisible index here is what is 1. So going to the next rule, that is division. When we have a raised to power x, when we have two ratios with the same base again, what does this mean? It simply means we subtract their powers, a raised to power x minus b. So when we have two numbers dividing with the same base, how do we operate it? We just simply divide the powers. For example, if I have 3 raised to power 4 divided by 3, for instance, I'm bringing the notion of, or let me just use 3 raised to power 2 here. So how do we go about this? The rule of indices that applies here is, because this is division, this is a ratio, what we simply do is to subtract their powers, 3 raised to power 4 minus 2, which is equals to 3 raised to power 2. The Next rule I would like to introduce here is when we have this is what we call the zero index. When we have a number or an expression or a variable raised to the power of a zero, for instance, a raised to power of 0, it is important to note here that okay, the a raised to power 0, that will equals a raised to power 0. I'm writing that again. That will equals to 1. What I wanted to write originally is that a in this case cannot be 0. So a 0 raised to power 0 does not apply. So any number other than 0, any variable, any expression other than 0 raised to the power of 0 will become 1. For instance, if I bring the division rule, if I have 2 raised to power 3 divided by 2 raised to power 3, this becomes 2 raised to power 3 minus 3, and this becomes 2 raised to power 0, and this becomes 1. So the next rule quickly is the power of a power. When a power is raised to another power, such that this a raised to power b, for instance, this is a power, it is now being raised to another power, let's say c. What would this result into? This would be a raised to power bc. So when we have a power raised to another power, what simply happens is that they multiply, the two powers multiply. If we have 2 raised to power 3, in bracket, raised to power 4, for instance, this becomes 2 raised to power 3 times 4, and it will be equals to 2 raised to power 12. So another rule is the negative index. The negative index, when we have a number or a variable raised to the power of a negative number, for instance, if I have a raised to power minus b, this becomes, that minus, the minus here, it becomes the reciprocal 1 over, then we have a raised to power b. So if we have a problem that results into, for instance, 2 raised to power minus 2, what this reduces to, the minus becomes 1 over 2 raised to power 2, which eventually becomes